Redis Labs has always been about empowering innovators, and today we think you're in for a real treat. We're going to discuss one of the final frontiers of information security, data in use. This is a problem in the industry, and it hasn't been fully solved and adopted. But we want to tell you about some of the innovators that are working hard day and night to find a solution to this issue. I'm really happy to introduce you to Eyal Yogev, CEO and co-founder of Anjuna, and Dan Middleton, a principal engineer at Intel. But first, we want to tell you why we think this is such a big problem in the industry, and what the industry is doing to tackle encryption in use. So we'll discuss the state of encryption. We also want to discuss Secure Enclaves with you. Secure Enclaves are the solution that the ecosystem of developers, such as Anjuna and Intel, are working to solve. We'll also discuss Intel's proof of concept with Redis, and what that means for Redis security and performance. Intel will then discuss at a technical level what their solution, Secure Guard Extensions, is, and the evolution of Secure Guard Extensions and the Enclave ecosystem. Now let's first go into the state of encryption today. Encryption everywhere has always been an ask from security teams, but it hasn't always been a practical solution for applications. There are three core requirements for encryption, and if you're an information security professional, you've probably heard of these. But if you're not, then this is probably a new thing for you. You've probably heard of encryption in transit, which is the ability to protect against unauthorized access between hosts. Between network connections, it's possible without encryption in transit to collect the data by intercepting network traffic. But the advent of TLS has generally solved this. Encryption at rest is another one of the core requirements, and this is generally intended to protect against unauthorized access and storage. Disk-level encryption has become commonplace across the industry, and it helps solve this today. So the state of these both are very commonplace, but the state of encryption in use is a completely different story. Encryption in use prevents unauthorized access while processing data. And this has not become very practical across the industry. There are some solutions, but these solutions have their limitations. Now let's discuss some of these limitations. Client-side encryption is a solution to encryption in use, but it doesn't work for every use case. Database functions that need to interact on data, such as comparison operators, incremental operators, or even search operators, are no longer able to function when data is encrypted client-side. Now, client-side encryption is essentially encrypting data before you store it in a database. That means that you're responsible on an application side to encrypt the data, and that's not practical for every use case. On screen is a demo of just why this has its limitations. You can see here, we're using OpenSSL to encrypt data and then storing it in Redis. Then we use an incremental operator and see this just doesn't work. How do we solve this? Well, luckily, Intel and Anjuna have been working really hard, and the industry as a whole has been developing an ecosystem that's gaining momentum fast. So I'm really happy to introduce you to Anjuna and Intel. You'll be speaking to Eyal and Dan more, and they'll go into what the ecosystem is doing to help us secure data in use. Let me first start by introducing you to Eyal.
Hi everyone, my name is Eyal Yogev and I'm the CEO of Anjuna. I'm here to tell you about the most exciting security technology that you've probably never heard of, which allows you to protect your Redis databases and other applications using hardware-grade encryption that completely protects the applications in memory, in storage, and on the network. Now, this technology is called Secure Enclaves, and it allows you to protect your Redis databases even from people with root access to the infrastructure that your Redis is running on. One of the major problems in security today is insider threats. Infrastructure insiders, people that have root access to your infrastructure, like your system admins, your reliability engineers, or the employees of the public cloud that you're running on, have root access to the infrastructure to manage it and deploy patches, but that also gives them complete access to the data within the applications deployed on that infrastructure. The problem only gets bigger when you think about third parties, like governments in countries where you're running on. They might get physical or root access to your infrastructure, or any compromised accounts with root access. The problem is that any security mechanism you use today can be completely bypassed by people with that level of access. One of the things people might do is use detection solutions, but the problem with detection is, one is by definition it's detection, it's after the fact, and two, people with that level of access can just go in and delete the logs, so you're not even going to know after the fact that anything has happened. This is why the CPU vendors have added a technology called Secure Enclaves into their server CPUs. Now, this includes a few basic building blocks that are added to every CPU. The first one is a hard-coded key that's embedded into the CPU as part of the manufacturing process. The second one is an encrypted memory space that is completely isolated from the rest of the memory. That encrypted memory space comes with a set of opcodes, allowing the process to save sensitive data into that encrypted memory, and the CPU itself enforces that only that process can access that memory, meaning not even the kernel, not even someone with root access can access that memory. Now, the third piece is something called remote attestation, and that is the ability to cryptographically prove that data is stored in that encrypted memory and that nobody has tampered with the encrypted memory. Now, this is now becoming the new industry standard. This was added by Intel, AMD, and ARM. It was added by the hypervisor vendors, and this is added to the different cloud solutions. This will be part of every server shipped in 2021 and part of most servers shipped today, and this will be supported by every public cloud out there. So what's the problem? This is obviously a great solution. The problem is, in order to take advantage of this solution, you have to go and rebuild every application that you have, which is something that I'm sure you're not keen on doing. And this is where we come in. We at Anjuna have built a solution called the Anjuna Enterprise Enclaves, which allows you to take an existing application and without changing it, run it inside of a secure enclave, and not only protect the memory using hardware-grade encryption, but also protect the data as it leaves the enclave into storage or into the network. We have partnered with Redis Labs to offer this for Redis databases, which means your Redis databases get complete protection across memory, network, and storage without having to change the database, without having to change the applications, change your processes, and without affecting the functionality of your Redis databases. And what this means is that your system admins, your reliability engineers, the employees of the public clouds you're running on can continue doing their job and maintain the infrastructure with the root access that they need without getting any access to the sensitive data within your Redis databases and within your other applications. So at this point, you hopefully have 4 questions. One is, how hard is this to actually do this? How hard is this to implement this? The second one is, how effective is this? Is what I'm saying actually works? The third one is, what is the performance impact? You obviously love the performance of your Redis databases. What is the performance impact of this technology? And the fourth one is, when can I have this? So let me quickly walk you through these 4 questions. So when you're running on a server that supports Secure Enclaves, you have 3 steps that you have to take. The first one is installing Anjuna on your Redis node, and we have a self-extracting installer to do this. The second one is changing the command from Redis server to Anjuna runtime Redis server. And there's no third step. This is as simple as that. These 2 steps and you're done. The second question was, how effective is this? So let me show you a quick 2-minute demo. In the first minute, I'm going to run a regular Redis database, and I'm going to add some sensitive information to it and show you how anybody can access that data both in memory and in the persistent storage once the database is terminated. I'm then going to run this again using the Anjuna solution, and you're going to see the difference. So what I'm doing now is I'm running a Redis database. And then I'm going to add some sensitive information into the database, mostly private information, just so we'll have something in there, so I can show you what an attacker might do to get access to that data. So I'm adding a name, I'm adding a social security number, and I'm going to add an address as well. And then I'm going to simulate what an attacker with root access might do. And what I'm going to do is I'm going to do a core dump, a memory dump, and then look for that sensitive information inside the memory. And as you can see, an attacker with that level of access can just get access to the entire data in memory because data in memory is not encrypted. both for Redis databases, but pretty much any other application that you're using. So obviously, as an attacker, I have access to all of that. But when I terminate the Redis server as well, you're going to see an attacker has access to the persistent data stored in the RDB file. And all that data is also completely transparent or in the clear for an attacker with that level of access. So I'm going to do the same using the Anjuna solution. And as you can see before I run this, the only change that I've made was adding the Anjuna runtime in front of the command. So as you can see, the Redis database is running without even knowing anything has changed. I'm going to do the same, adding the same sensitive information into the database. And then I'm going to run the exact same attack after this, the same memory scraping attack. So I'm going to run the memory dump again, the core dump, and going to look for the sensitive information inside the memory. And as you can see, an attacker cannot get access to that data in memory because the entire database is now running inside of a secure enclave. So the entire memory is completely encrypted. And when I terminate the server, and I'm going to show you the RDB file, as you can see, that RDB file is completely encrypted as well, and an attacker cannot get access to that data as well. So the third question was about the performance. So we've benchmarked this on both Intel SGX as well as AMD SEV, which is the AMD solution, and I'm super proud to say that we achieved the sub-millisecond latency that you know and love from your Redis databases. These are some of the Intel benchmarks, and I'm showing now the AMD benchmarks. But the exciting thing about this is that this is only going to get better as we improve the performance, and as Intel and AMD are making hardware improvements to their technologies, which is only going to make the performance better. Now the last question that you hopefully have is, when can I have this? So this is available today for the open source version of Redis on the Azure Marketplace. If you're running on Azure Confidential Computing, which is the Azure instances with Intel SGX on them. If you want to use this on any other clouds or within your own data centers, just email us at redis@anjuna.io and we'll be more than happy to give you access. Now the most exciting news is that this is coming to Redis Enterprise. We'll have more information coming later this year, and you can email us at redis@anjuna.io or contact Redis if you want to be kept informed or if you want to be a beta site for this. So at this point, the last question you probably have is, do you want to run the secure version of Redis or the regular version of Redis? As I mentioned, this is super simple to implement. There are no changes to the workflow, and it doesn't change the functionality of Redis. This is free for the Redis open source version, and you can contact us for details, and it's coming to Redis Enterprise. Please email us at redis@anjuna.io for details, or if you want to be a beta site for this. Thank you very much.
Thanks, IL, and we're really excited about this partnership. More to come soon. Next, I want to introduce you to Dan Middleton. Dan is a principal software engineer at Intel, and he's one of the members of the Enclave ecosystem. He's here to tell us a little bit more about how Intel is evolving the Enclave ecosystem and how Intel Software Guard Exchanges is changing as it evolves.
Hi, my name is Dan Middleton. I am a principal engineer at Intel, where I focus on distributed systems and cryptography. And if that sounds fun to you, I know it's fun for me. I get to work on really interesting problems and get to work with new technology. And I do it in a company that respects and promotes diversity and inclusion, which means that we've got people from all sorts of backgrounds here, and that means that I get to work with some of the brightest minds in the industry on this. Also, a lot of the work that Intel does with SGX is open source, and that gives me a whole nother opportunity to engage with a variety of people and learn from them outside of Intel as well. And then, of course, I get to come to conferences and speak to people like you, though we're not going to be able to do that today, which is disappointing. But we put all the more effort into this presentation, so hopefully you get something useful out of this. So, let's jump into it here. In the Anjuna presentation, you got reminded, of course, of the importance of protecting data at rest and data in motion. And for some of you, maybe it was the first introduction to the idea of protecting data in use. And the idea with that, again, is that we go to all this effort to do things like disk encryption to protect it at rest, or making sure that we've got TLS sessions, that we're sharing data across a network. But then when it actually comes time to make use of that data, we load that into memory in the clear, because that's really the only way that we have to execute on that data. Now, Intel, years back now, looked at this problem and they thought about, well, what could we do to actually protect data while it's in use like that? What would be the threats against that security objective? Now, normally, you've got a lot of processes on a system in addition to the one that you're trying to protect. Some of those could be malicious processes. All of those processes are going to rely on the operating system. That operating system has usually a lot of third-party drivers. You might have sockets open for required services. Really, there's a pretty big threat surface with the operating system that you want to be able to guard against. And then in some cases, that operating system itself is relying on another layer of software below it from a VMM. So our researchers thought about, well, what could we do to shrink these layers down so that the entirety of what your application is relying on for its own security, which we call the trusted computing base, is minimized. And what they came up with was, hey, instead of trying to make these things smaller, what if we could actually just not rely upon them at all? And that it became what we call Intel Software Guard Extensions, or SGX. And that in its entirety is a set of architectural enhancements that includes some CPU instructions so that your application can designate a portion of it as security critical, or in the case of Anjuna launching Redis, it's going to declare the entirety of the application security critical, and that gets loaded into a special kind of memory that's controlled directly by the processor, so that even if the operating system is compromised, the operating system doesn't have special privileges that let it read that memory. And we talk a lot about protecting the data because that's important, but one of the ways that we go about protecting that data while it's in use is we need to know that the application that's working on the data is the application that you want working on that data. So when you load an application as an enclave, or you load a library of your application as an enclave, what the CPU does is it takes a measurement of it. And you can think of that simply as taking a cryptographic hash of the memory. And that is effectively the identity of your application, including its instructions. So remember that normally when you load an application into memory, it's got not just the heap and the stack for the memory, but it also has the section with the instructions in it. So all that, including your code, gets measured by SGX, and you get a cryptographic identity for your software. So now if it's been tampered, that tampering is evident, and the application won't be allowed to load if it's going to be trying to load into an enclave. The other thing that lets you do, now that you have got a cryptographic identity for your application, is that you can remotely attest to that, or you could locally attest to that to other processes on the system, or remotely being you want to launch this program on another machine and be able to trust that it's running securely on that machine. You can build compute models out of that attestation, which is a little bit outside the scope of what we'll get into in the rest of this presentation. But it's an example of building that hardware-based trust for your application and your data. And when I come to a setting like this, sometimes people are hearing about SGX for the first time, and it sounds like it's a very new technology. But actually, Intel launched this technology a number of years ago now, but we launched it with client CPUs. So like things that you would put into a personal computer or a high-end workstation. And what we found over the years is that we have increasing demand for it in the server space. And of course, that only makes sense that we've got very valuable information that gets worked on in databases and other server class applications, and there's strong demand to keep that protected there. Along with that has been a growth in the ecosystem around it, not just around database usages for it, but you could look at a whole variety of use cases that are looking to benefit from trusted execution, to the extent that we now have hundreds of service providers and software vendors building products around this technology. But when it came out, it was a very novel idea that you could actually try to protect the execution and protect the data that is being executed on. And that got the attention of a lot of the research community. And so we've really benefited and been able to harden SGX to the point that it's at today. Now, looking forward, we're going to continue that server momentum into these data center class applications. And things like Redis are only going to benefit from having more memory available to them. So you'll see increased enclave page cache sizes. So the enclave page cache is that special area of memory that the CPU is controlling. That's going to be increasing substantially. And like security, performance is something of an addiction at Intel. We're always thinking at every stage of the process lifecycle of the product lifecycle rather. What can we do to make this more efficient? What can we do to make this stronger? So you'll be seeing some acceleration features coming into software guard extensions over time here. And then also as we expand into the class of applications that take place in data centers and cloud service providers, these have an increasingly diverse set of requirements. And so we'll be working on increasing the envelope from SGX to protect other elements of compute that are required by some of these interesting use cases. The other thing that you're going to see expanding, that you're going to kind of see this real time, is the ecosystem. In the second half of 2019, Intel, along with a lot of the other logos that you see on this slide, launched the Confidential Computing Consortium. This is an open source organization that's looking at strengthening and improving confidential computing and working together in a transparent way on it. And this is just a subset of the names that are a part of the consortium. It is an open organization. Your company is welcome to join, or you're welcome to just take advantage of a lot of the open source work that comes out of it. But maybe one thing to notice with the names on this is that this is not just a chip-based consortium. You'll see a lot of cloud service providers on that list, software vendors like Anjuna, companies that are either creating products around it or requiring the capabilities that those products provide. And so having that balance of adopters and producers of the technology is something that's really healthy for the industry. And so we're really excited to see this go and pick up steam right now. Finally, the kinds of things that become possible when you can remotely attest to the integrity of your application gives rise to a lot of interesting use cases and things that you might be working on, like blockchain, federated learning. There's really a whole variety of things that become possible when you know that you can trust the remote endpoint that you're sending data into, and importantly, that you can trust the responses that come back. You know that the result of that execution matches the integrity of the application that you wrote it with. So you can find about those and a lot more at the URL there. And I hope you enjoy the rest of the virtual conference. Thank you.
Ayel and Dan, thank you so much for the time you've invested in RedisConf. Anjuna and Intel are doing great work to develop the Secure Enclave ecosystem. I truly believe that Secure Enclave technologies are the coolest thing happening in the security industry today. As this community of hardware providers, cloud providers, and software to make development with Secure Enclaves easier develops and evolves, it's time for applications to begin to adopt Secure Enclave technologies. There's more to come in the Redis community soon. As Ayel mentioned, we're starting a partnership with Anjuna to see how we can take Secure Enclaves to Redis Enterprise for our commercial customers. We're just beginning this process, but we're excited about the potential ahead. Stay tuned for more details about the evolution of Secure Enclaves and Redis Enterprise as this partnership develops. Thanks for your time.